The moon was erupting volcanoes while dinosaurs walked the Earth. Recent discoveries from China's Chang'e 5 mission have completely rewritten what we thought we knew about lunar history. Scientists have uncovered volcanic activity on the moon from just 120 million years ago, far more recent than previously believed. This finding suggests that the moon, long thought to be geologically dead for billions of years, remained active much longer. And the big question now, could it still be volcanically alive beneath its surface? Stay with us as we dive into this groundbreaking discovery and what it means for the future of space exploration and planetary science. China's Chang'e 5 mission, launched in November 2020, marked a monumental step in lunar exploration. This mission aimed to collect samples from a specific region of the moon known as Oceanus Procellarum, or the Ocean of Storms, an area believed to have experienced volcanic activity billions of years ago. However, Chang'e 5 didn't just repeat history, it made new history. When the probe returned with 1.7 kilograms, 3.74 pounds of lunar soil and rock, scientists were excited to analyze the material. Among the most surprising discoveries were 3 tiny glass beads formed by volcanic activity. Through advanced dating techniques such as uranium-lead dating, scientists concluded that these beads were only about 123 million years old. This was a revelation because the prevailing assumption had been that lunar volcanic activity ceased around 1 billion years ago. These beads, however, told a different story. The age of these volcanic glass beads suggests that the moon was volcanically active during the same period when dinosaurs roamed the Earth. This timeline disrupts long-held beliefs about the moon's geological history, offering new insights into the cooling process of smaller celestial bodies. Smaller objects, like the moon, are expected to cool and become geologically inactive relatively quickly after their formation. But the Chang'e 5 samples suggest that volcanic activity on the moon persisted much longer than we ever anticipated. The question of what kept the moon volcanically active remains one of the most exciting puzzles arising from this discovery. There's speculation that certain radioactive elements in the lunar mantle, such as thorium and uranium, may have acted as heat sources, prolonging volcanic activity. However, the evidence gathered from the Chang'e 5 samples doesn't show abnormally high concentrations of these elements, leaving scientists to ponder other potential mechanisms. This discovery forces us to rethink not only the moon's past, but its potential for geological activity in the future. The discovery that the moon was volcanically active just 123 million years ago opens up a wide array of new questions. One of the most pressing questions concerns the moon's thermal evolution. Previously, scientists believed that the moon cooled relatively quickly due to its smaller size, and that volcanic activity had ceased over 1 billion years ago. However, the Chang'e 5 mission suggests that volcanic activity continued much longer than expected. This means the moon's internal heat must have been sustained somehow, possibly through the decay of radioactive elements or other mechanisms. One theory suggests that heat-producing elements, such as uranium, thorium, and potassium, could have kept certain regions of the moon's mantle warm enough to allow magma to form, even long after most volcanic activity had ended. These elements are known to generate heat through radioactive decay, which could explain the longevity of volcanic activity on the moon. However, the analysis of the Chang'e 5 samples found no significant concentrations of these heat-generating elements. This leaves scientists with a tantalizing mystery. What was the source of the heat that fueled these late-stage volcanic eruptions? One possible explanation is tidal heating. As the moon orbits Earth, the gravitational forces between the two bodies could cause internal friction within the moon's mantle, generating enough heat to produce magma. This tidal heating could have localized effects, potentially sustaining volcanic activity in certain regions while the rest of the moon cooled. The implications of this discovery go beyond just rewriting the history of the moon's geological activity. It also raises questions about how we date planetary surfaces. For years, scientists have used crater counting to estimate the ages of different regions on the moon and other planets. The idea is that the more craters a surface has, the older it must be. However, if volcanic activity on the moon continued much later than we thought, this method of dating may need to be revised. The Chang'e 5 findings could lead to a reassessment of how we understand not just the Moon, but other volcanic bodies in the solar system, like Mars. The Chang'e 5 mission has reignited interest in the Moon's geological past and its potential for future exploration. With evidence of volcanic activity as recent as 123 million years ago, the Moon might not be as geologically dormant as we once thought. This discovery opens the door to exciting possibilities for future lunar missions, particularly China's upcoming Chang'e 6 mission, which is set to collect samples from the lunar South Pole. The South Pole is of special interest because of its vast ice deposits, which could provide critical resources for future lunar bases. However, with the possibility of localized volcanic activity in relatively recent times, this region could also yield new geological insights. This discovery also presents a unique opportunity for planetary scientists. The methods used to date the volcanic glass beads from Chang'e 5 could be applied to other celestial bodies with volcanic histories, such as Mars. Mars is believed to have had volcanic activity far more recently than once thought, and the techniques refined through lunar exploration could help unlock the red planet's volcanic secrets. The possibility that the Moon could still harbor active or semi-active magma chambers beneath its surface adds a new dimension to our exploration plans. Some researchers have begun to question whether future missions could uncover signs of ongoing geological activity, such as transient lunar phenomena, flashes of light, or color sometimes reported by astronomers but not yet confirmed by space probes. These phenomena could be linked to small-scale volcanic events, which might still occur on a localized level. For future human exploration, this discovery also highlights the potential of the Moon as a resource. Understanding its volcanic history could provide clues about the availability of materials like helium-3, a rare isotope that could be used for future fusion energy. Additionally, studying the Moon's prolonged volcanic activity could help us better understand Earth's own geological history, as both bodies share a similar formation history. In this video, we've uncovered the fascinating new findings from China's Chang'e 5 mission, revealing that the Moon experienced volcanic activity far more recently than we ever imagined. We've explored how this discovery challenges our understanding of the Moon's geological history and what it could mean for future lunar exploration. We hope you learned something new today. If you did, please give us a like, share this video, and subscribe to our channel for more exciting space content. Don't forget to leave a comment below. Let us know your thoughts on this groundbreaking news and what topics you'd like us to explore next. We'd love to hear from you. Thanks for watching, and see you next time.